Hi students, I'll try in this educational video to technologically introduce the axial connections as simply and as clearly as possible. Okay, let's go. Well, first I'll introduce the concept of axial force transfer through bracings. So let's consider the steel frame erected on the ground. Beams are depicted in red while columns are depicted in black, and the ground is depicted in brown dots. And let's consider that all connections between beams and columns and between columns and foundations are shear connections as it is depicted in blue. And as I explained in a previous video, the shear connection cannot carry bending moment. Now, if we apply a lateral load in the span direction as it is depicted, the 2D simple frame constituting the 3D frame will be subjected to bending moment and will rotate as it is depicted by hashed lines, which provoke the instability of the steel frame. In order to avoid this problem, we have to add a bracing as it is depicted in green. This bracing will permit to directly transfer the lateral load to the ground as an axial force through the bracing. This will avoid the problem of instability that I explained before. Also, this lateral load can be applied in the other direction, which is the bay direction, and the adding of a bracing as it is depicted in green will permit also to transfer or to directly transfer the lateral load to the ground as axial force through this bracing. The considered lateral load is principally wind load or seismic load. Thus, the axial force transfer should be directly carried out from the beam column intersection to the column foundation intersection via the bracing. In order to ensure a correct axial force transfer, we have to add an axial connection column beam brace between the beam column intersection and the bracing, and also we have to add an axial connection column base plate brace between the bracing and the column foundation. Now I'll introduce, let's say, the first type of axial connections, which is based on the use of gusset plate in order to make the connection between column, beam, and brace. So as you can notice in the figure that you see in this slide, we have a gusset plate depicted in green. This gusset plate is directly welded to the beam and also welded to the brace, and is connected to the column using a shear plate. This shear plate is bolted to the gusset plate and welded to the flange of the column. Other varieties of this type of axial connections can be carried out. For example, the one that you see now in this slide. So as you can notice, it's almost the same technological solution, except that the connection between the gusset plate and the column is carried out using an angle instead of a shear plate. The angle is bolted to both the gusset plate and the flange of the column. The gusset plate can be also directly welded to the beam, the column, and the brace as it is depicted by the figure that you see in the right of this slide. It's to note also that if the beam is connected to the column using an end plate as it is depicted by the figure that you see in the bottom left of this slide, this end plate can be extended to integrate the gusset plate, and as you can notice in this figure, the gusset plate is welded to the beam and welded to the end plate. And you can notice also that the brace can be connected to the gusset plate using a bolting instead of a welding. Well, it's important to note here that I explained just some technological varieties of gusset plate axial connection between column, beam, and brace, and there are other technological varieties based on the same principle that I'm explaining now for this type of axial connections. And the figure that you see in the middle or in the bottom middle of this slide is a real picture indicating a gusset plate axial connection between column beam and brace. And as you can notice, the brace here, we have a double brace bolted to the gusset plate, and the gusset plate is welded to the beam and the column. For the real picture that you see at the bottom right of this slide, you can notice that the gusset plate is directly welded to the beam and the brace, and it's connected to the flange of the column using an angle bolted to the column and also bolted to the gusset plate. Now I'll introduce the second type of axial connections, which is based on the use of gusset plate to make the connection between column, base plate, and brace. So as it is depicted by the figure that you see in this slide, we have a gusset plate directly welded to the column and the base plate, and we have a double brace bolted to this gusset plate. So we can use a single brace instead of a double brace, and also the brace can be welded to the gusset plate instead to be bolted, as it is depicted by the real picture that you see at the right of this slide. Here you can notice that the gusset plate is directly, or the brace is directly welded to the gusset plate, and the gusset plate is welded to the flange of the column, and here it's also directly welded to the base plate, but you cannot see the base plate because it's under the concrete slab. Now, it's to note that there are other types of axial connections. We have principally the connections between the tension members and the compression members of trusses, whether it is bridge trusses or roof trusses. And as you can notice in these figures, trusses can be simply seen as technological arrangements of bracings. And I will explain trusses in detail in terms of technology and resistance verification in the next educational video. There is also the splice connection as it is depicted by the figure at the bottom left of this slide, and in a previous educational video I presented this splice connection as moment connection since it carries bending moment and shear force, but this splice connection can be also considered as axial connection since it primarily carries axial forces. Well, there is another important type of axial connection, which is the hanger connection, as it is depicted by the figure that you see at the bottom middle of this slide. The hanger connection is widely used in the tied arch bridge, and this connection, the hanger connection, can be simply seen as a type of bracing called hanger. And here we have a double hanger. It can be simply a single hanger. The hanger is pinned to a plate, and the plate is welded to the bridge arch, as it is depicted by the figure that you see at the bottom right of this slide. Well, this educational video takes end. If you have any questions, remarks, or suggestions, please mention it in the comments. Thank you very much for your attention.